Good afternoon. Welcome to the .NET Frameworks Patterns and Practices talk. So this is what this next hour or so is going to be about. So if that's not where you want to be, this is your time to take off. But I encourage you to hang out because this is going to be a really cool talk. There's a lot of neat information I'm going to be giving you today. I don't know about you, but after being to the general session and all these breakouts, I feel a little bit like I've been drinking from a fire hose. There's just all kinds of information that we're giving you. And I'm sure that it just feels like there's a whole bunch. And I hope that this talk will be one of those talks that brings it together for you. We're not going to introduce tons of new concepts, but we're going to knit those concepts that you already know together and give you something actionable that you can do and take home as you write your own libraries and your own business objects. I hope that in the other sessions and breakouts that you saw one of the things we're trying to do with the .NET frameworks is make it easier to write applications. What we're trying to do is make the developer hour much more productive. We're doing that through things like the automatic memory management. We're doing it with enhanced RAD features in Visual Studio and new language innovations. And another way that we're doing that is by having consistent patterns and practices in the frameworks. Those cool RAD features don't do you any good if the methods that you use are hard to understand, if the documentation isn't there, if you really don't know exactly how to use these features. So it's been about 2.5 to 3 years now ago when we started work on the .NET frameworks. And at that time, we recognized how important it was to have a really consistent API set. And a few of us sat down and came up with a set of design guidelines, some patterns that we could use as we built the frameworks. And through time, as we had 100+ developers working on the frameworks, and through the course of 2.5 years, we've honed those patterns through practice. We've written millions of lines of managed code, and we've learned a whole lot about what it is to write managed code, what are the tips and tricks that you should be aware of. So that's what I'm going to be sharing with you today. So what are we going to learn? We're going to examine some best practices for writing managed code. We're going to see how those patterns are used in a sample component that I've written. I'll tell you more about that in a minute. And I'm going to help you understand how, when, and why to use these patterns. So let's jump into the sample first. One of the first decisions we made when we started developing the frameworks is that the reference material or the documentation is very key to understanding, to having a consistent framework, having a framework that's very easy to use. So we've chosen to put our documentation inline in the source code, right next to the source. I'll show you an example of that. And that's so it's right there where a developer can come and edit it. When he changes the code, he can also change the documentation. It really gives you, the customer, of that documentation, real first-class experience. So what the C# compiler will do if you throw the /doc switch is it'll, in addition to generate your assembly or your DLL, it'll also generate an XML file that contains that documentation. So when I first saw that, I thought, oh, this is way cool. So I built a little library that uses the advanced XML parsing classes we offer in the frameworks. And I parse that XML and return it back in a programmatic way. And that's doclib. So let's look at an example of that real quick. Can I swing over to the sample machine? Demo machine? Excellent. So you can see this is a C# library, and you can see this is an example of the in-source documentation that we offer. This is actually the code that goes through and parses this documentation, and I'll just point out a couple of things about it. This, when I wrote this library, I intended it to be used by multiple different languages and different kinds of applications. You'll see that in just a second. So because of that, I put the CLS compliance attribute on there, and you might have heard a reference to the CLS in previous talks, and we'll talk more about it there. But it's the contract that ensures that your library is going to be used from any language. So I set that on there. And so once I got this library, I got thinking, so what should I do with this library? So the first thing I thought is, I think I need a really rich client application that will use this documentation and display it to the user. So I wrote a WinForms application in Visual Basic that leverages this shared library. So I took this library, compiled it to an assembly, and stuck it in a common location where these other applications could get at it. So the first one I wrote was a Visual Basic one. And you can see it's a rich client application. I have some pretty lame icons that I drew. And it returns the sample documentation. So when you take a look at that, you can see it is written using Visual Basic. So we just scroll down through here, and you can see that this is where we're leveraging the shared assembly that I have written. So then the next thing I thought is, okay, that's good. Rich client apps, that's a good thing. But I caught John Shuchek talk, and he told me that web services rock, and I should really be exposing my stuff as web services. So I thought, okay, so that's what I'll do. So I thought, well, web services, they're the brand new thing. They're the thing that's sort of very innovative. What language should I write that one in? I thought, you know, there's a language that is just perfect for this, and that's COBOL. COBOL is just a fabulous language for doing this type of thing. So that is what I have written this web service in. And you can see it's, actually, if you know COBOL, you can see. Otherwise, it looks like a bunch of all uppercase. But what this simple web service does, let me give you a little demo of that. This simple web service returns the documentation for a library. And you can see this is the debug view. You might have seen it before. It gives you an opportunity to interact with your web service as you're developing it. And I'm going to just invoke this right now. And what's happening behind the scenes here is that COBOL code is being compiled on the fly, and it's being executed, and the result is being returned back as an XML blob. And you can see the documentation I got back is in XML here. So then I got to thinking, wow, because I follow the patterns and practices of the .NET frameworks, this library is very usable from all these different languages. What's the next language and app type I should use when I'm to show off this cool library that I've written? So I decided to build a class browser. A class browser is one of the first apps a lot of people build when they start targeting the frameworks because we have such rich metadata and such an easy reflection API. So that's what I did. Actually, the truth is, I stole this code out of the SDK, and I encourage you to do the same thing. So I stole this code out, and I added the documentation material. So you can see I'm actually showing the documentation for my own library again. So that's my own library, doclib, and it has these classes in it. And you can see that in addition to returning the information that reflection gives me, I'm also returning the documentation for those members. So we can switch back to the slides. You can see these are the different apps that we built, and they all use the common doclib shared library. And I was able to do that. I actually wrote the library before I wrote these other applications. And I was able to be assured that whatever applications I decided to write would work in whatever languages because I followed the design guidelines and patterns of the .NET frameworks. So first, a word about design guidelines. Throughout the 2.5+ years we've been working on the frameworks, we've had lots of heated discussions about design guidelines. And when I'm talking heated discussions with Microsoft engineers, you know I'm really talking about heated discussions. So I'm sure as we go through these guidelines today, there's going to be a lot of questions and differences of opinions that you have. And I would love a chance to talk to you about them, but this isn't the forum to argue about them. So afterwards, if you can come up and we can debate then. But many of these design guidelines have no truly right answer. I'm going to tell you what we decided and why we decided it, what the inputs were to that decision. But in the end, the decision's really up to you. Microsoft's not saying this is the only way to write code. But I think there is a lot of power in you using the same design guidelines that the rest of the frameworks does. Because we have a shared customer, don't we? You're writing libraries, you're writing business objects that either internal developers or maybe even some third-party developers will use. And those guys, in addition to using your library, will be using ours as well. And there's a lot of synergy we can get if those libraries fit together very seamlessly. So I encourage you to think carefully about these design guidelines and follow them wherever you can. So the first thing I want to mention is about the common language specification. As I mentioned before when we looked at the source code, the common language specification guarantees interoperability between languages. Many languages have features that other languages don't have. It's especially true when we deal with some of the more exotic languages like COBOL, but it's also true for interoperating between managed C++ with managed extensions, C# and VB. If you want to ensure that whatever the next language that, the language du jour is that comes out, that your component will be able to work well with it, you should target the CLS. So traditionally up to this point, you've had to pick the language that you wanted to target. You've had to say, I really love Python, but there's 50 bazillion VB users or whatever the number is. But at this point, you no longer have to pick a particular language. Using the CLS, you will be able to target any language. Now, when we were first coming up with the common language specification, we considered having a really small set. What is the actual proper subset of all languages in the world? And that turned out to be a very small, unusable set. The least common denominator solution wouldn't allow for rich, usable frameworks. So we opted to have a very rich and coherent definition of the common language specification instead. And that's created a little bit more work for the third-party compiler guys, but nearly all of them have been able to get CLS compliance in there. And the other beauty is that there's a big doc that you can read. I encourage you to check it out. But there's really not a whole lot that you have to go do. Just go put that CLS compliant custom attribute on your assembly, and the C# compiler will give you warnings or errors as appropriate whenever you stray outside of the common language specification. Okay, naming patterns. The key thing about identifiers, that's method names, property names, type names, namespace names, what have you, is that they be readable. Legibility is very important and expressing the idea to the user. So what we've done to create some readability is we've avoided the use of abbreviations. There are a handful of abbreviations used in the frameworks, and those are primarily because the abbreviation has entered the common lexicon as a word. We don't spell out HTML, for example. Don't use underscores and all caps. All caps feels like you're yelling at the user. Why are you using all caps there? And also, don't use Hungarian notation. Whoa. So we went through these slides several times, and people kept telling me, oh, you're going to get booed for that. So glad I didn't. Really, there's no need for Hungarian notation in the common language runtime now. We have much stricter type checking in the libraries, and the development tools make it much easier. So we don't use Hungarian notation at all in the frameworks. And my other example, again, not all uppercase and no underscores. So in our many arguments about naming patterns, we've had to create some terminology so we could argue more effectively. So we've come up with the terms Pascal casing, and Pascal, we call that because it's pretty common with many Pascal languages. And it's initial upper, where each word following is initial upper. And camel casing sort of has a hump in it. It's initial lower, and each word's initial upper. So here's an example pulled out of the code that I flipped through earlier. There's a member doc class, and it's Pascal cased. Compare to method, and you notice it's Pascal cased as well. And the compare to has a method that takes compare to is a method and has a parameter that takes a value, and it's camel cased, as well as local variables being camel cased. And then I have a property called name, and that's Pascal cased as well. I'll give you a little insight into how we got here. We really felt that single letter variable names, single letter parameter names would be common, A, B, C, for example. And we felt like those needed to be camel cased. It really wouldn't make sense to have an all uppercase A. That would seem a little bit weird. And so local variables followed nicely from that. And then we felt like we needed to differentiate that from methods when you're making a method or a property call, so we changed the case there. And then it just seemed natural extension to have type names be substantial and Pascal cased as well. In addition, this naming pattern is pretty common to many of our users. It's the one that's commonly used in VB today. But the most important thing about a naming pattern is that it's used consistently, so that you actually get some meaning. If it was, no matter how great the naming pattern is, if it's used arbitrarily, then you as users or our common users don't get any benefit from that. So error handling. We use typed exceptions rather than error codes. If you're at all familiar with programming to the Win32 APIs today, you're familiar with H results and S codes. And you might be familiar with the fact that these are somewhat error prone because we frequently forget to check for the return code. So we find that in code from users, and we find that code in our own libraries. With exceptions, errors, if you don't handle your error, your caller gets a chance to handle the error, and his caller gets a chance to handle his errors. So whereas with error codes, if you forget to check your error, you just get incorrect results. Your program crashes later on, or worse, does something incorrect later. So we feel like by the frameworks using error handling, it creates much more robust, you're able to create much more robust applications. So we don't use error codes at all in the frameworks. So that said, good, error codes, goodbye, that's a good thing. That said, it's not always the case that an error code is appropriate. For example, if I'm reading byte by byte to the end of a file, and I hit the end of that file, that's really not an exceptional situation, right? I mean, every time I read through the file, I'm going to hit the end of a file. So it's really not appropriate to use an exception in that case. The key thing about exceptions is that they should be used in exceptional situations. Now, I want to juxtapose exceptional and common because they're not actually the same thing. For example, if you play around with our net classes, you'll notice things like 404 errors and networking errors. We throw exceptions for those in our networking classes. And we do recognize that those things are very common. And while they are common, they're also exceptional situations because your application is probably going to have to handle those errors in different ways. So for even common exceptional cases, we use exceptions. So properties and methods. You might have heard that the frameworks, the .NET frameworks, offer both properties and methods, and this really does a lot for class library design. You're able to express a lot more about your intent when you're building the library by using properties and methods. But that really loses some of its meaning if it's used inconsistently. I've noticed in my dealings with people writing managed code, there seems to be two types of class library designers in the world, and I'll let you pick which one you are. There's those that think properties should be used for everything, and they use a property all the time. And then there's those that never use properties and always use methods. So that gives you, if you recognize who you are, you know where to error on. So because of that, we've had to create some patterns, some rules about when you use which one. So a property should be used when there's a logical backing store. So if you're abstracting a field in your class away as a property, or in the case of the system.type class, we have this name property. And there's actually no variable or no data member on the type that's the name that we're exposing. The name of the type is stored way down deep in the bowels of the common language runtime. And when you call out, we go and fish it out and trim some stuff off it and return it to you. So there's no actual data value there. But we use a property because it's logically a data value. As you use it, as other people use it, they notice that it feels like a data member. And I want to juxtapose that to the method we have on the GUID class. Yeah, I know that we don't need GUIDs in the .NET frameworks anymore, but occasionally it's necessary to get out to unmanaged code with GUIDs. And we have a method that generates the next GUID in a series. It takes the GUID you have and just generates the next one. And this really isn't appropriate to be a property, even though it begins with get. It's not appropriate to be a property because it's really performing an operation. GUIDs don't, by their very nature, have a next on them. So some more rules about when to use a method. So you should use a method if the operation is logically a conversion. We use methods in this case. If the getter has an observable side effect, this is not if you're caching. You know, for example, in my name example from type, we do some caching, and that's perfectly okay as long as the user can't detect that you've done it. The key point is that users expect to be able to call properties in any order, and if order of execution is important, then users will get confused. So to illustrate that, let's switch back over to the demo, and I want to show you some code. So this is some code that we had at one time in our library, and I seem to have lost it. So we had a connection class in our library, and we've changed some designs so we don't have it. And you'll notice that this connection class has 3 properties on it. It has a property for the DNS name, a property for the password, and a property for your username. But then it has a method for execution. You'll notice that in just a second. It wouldn't be appropriate to have used a property for the execution because the execution needs to happen in a certain order. You need to have set those 3 values before you call the execution. So flipping back over to the slides, we learned this next bullet through trial and error. If a member returns an array, that shouldn't be a property. So for example, if we have an employee list and it has an all property on it, and this all property could return an array of employees, and that array of employees is a copy of the elements in that list. So each time through this loop, we're taking L and we're calling the all property on there, which creates a copy of the array. We're indexing into it and throwing that value away. So each time through, we call the all property, copy the array, index into it, throw the array away. And as you can see, that's like n times through this loop, we're going to be creating a copy of that array and just throwing it away. So this is some pretty inefficient code, and we've led as class library designers, we led the user down the road of writing this inefficient code. Even though we offer a more efficient way to do it, we've sort of deceived the user in a sense into writing bad code. So if instead we had followed the design guidelines and practices and not have had this property, but made it a method instead, it would have looked like this. And you can see that looks a little bit odd. If you were doing a code review and you saw this piece of code, you probably wouldn't have even written this code, it looks so odd. But it does about the same thing. So when the user sees that he's having to write code like this, he'll probably go and find the way we intended him to do it instead of this inefficient way. Okay, threading. This is one of the areas where your knee-jerk reaction is maybe not what we did. You might think, well, wow, the framework should have really made everything thread safe so that we don't have to so that as users we don't have to worry about threading issues. But the threadworks are free-threaded by default, and free-threaded is a nice way of saying that they're not thread safe. So why did we do this? I will motivate why we did it. This avoids deadlocks and lock contention. If you've done some performance analysis before, you've tried to figure out where your lock contention is coming from, and you know it's a very difficult thing to track down. And you can imagine if every layer of the frameworks had took locks all over the place, that lock contention could get very difficult. In addition, and possibly most importantly, the ASP Plus and WinForms user models don't actually only allow a single thread of execution at a time through user code. So the common language runtime and the ASP infrastructure actually keep only one thread at a time coming through your code. So your code on the page doesn't have to worry about free threading issues, and libraries you use don't have to worry about it either. It is important to mention what the exceptions to that are. There's static methods, there's session state and application state, where you're actually not guaranteed that. And in the next slide, I'll show you a little bit about how we deal with some of that. And if you are writing an application that has to deal with multiple threads, you're able to take locks at a more appropriate granularity. It's very unlikely that all you're going to want to do is add an item to a hash table. You're probably going to want to add an item to a hash table and send it out over the network or something. And now you're able to take the lock yourself over both operations. But we do have a rule that static methods must be thread safe, and that has to do with in the ASP model, statics on the page need to be thread safe. So all the static methods in the library are thread safe. And many of the classes in the frameworks are actually thread safe by default. Just as part of their design, they're thread safe. So for example, the console class, that's how we do console.writeLine. We print neat stuff out to the console window. It's thread safe by default. And you can reference the documentation to determine which ones are thread safe. But we do recognize that threading is in the world, so we have several patterns for getting thread-safe versions of the classes that we have in the frameworks. The first is there's an immutable pattern, and that's probably the most common. All the value types we have are immutable, as well as all the base types. For example, string is immutable. And because there are simple immutable types, there's no place to set data. We offer no way to set the data in a string, so it's thread safe. In addition, for example, in the data set, we have a read-only method, and the way that works is you create your data set and you start reading stuff out of it and poking stuff into it, and then you call read-only. And once you call read-only, all the write methods or edit methods throw. They no longer work. So from that point on, once you've called read-only, it basically follows the immutable pattern. At that point, it's safe to pass that out to a free threading environment. And in addition, we offer a synchronized pattern as well. So for the I/O classes and the collection classes, you're able to, for example, create a hash table, populate it as you will, call synchronized on it, and that returns a synchronized wrapper to the hash table. So all the calls in to add or remove methods from it take a lock and make sure that the appropriate thing happens. So memory management. This is probably the biggest thing to get used to as people come from programming in the C++ and to some extent the VB world as well. We've had an opportunity to talk to a lot of developers internally as they start targeting our platform. And this is one of the bigger things they have issues with. So I want to spend a little bit of time on it. As you might have heard from other talks, we have a kick-butt GC. It does a really fantastic job at managing memory. And I want to tell you a little bit about one of the ways it's optimized. It's optimized for small, short-lived objects. And for objects that are small and don't live very long, the GC actually ensures that they stay on the L2 cache on your processor. So that's right on the processor. So to allocate and collect those objects, we don't even have to go all the way out to main memory and back. It stays right on the processor. And because of that, we can allocate, that is create, and collect, that is clean up. So we can allocate and collect an object in 45 clock cycles. To put clock cycles in perspective, that's about 10 million objects per second on my machine. I know I'm sort of just throwing numbers out at you now, but I encourage you to go back and take the bits you have and do a little experimenting with the GC and convince yourself of the performance of the garbage collector for these small, short-lived objects. So, well, what does this have to do with design patterns and practices? Well, what it means is you no longer have to avoid creating short-lived objects. You should be able to create temp objects wherever it makes your programming model easier. So the example of code that I have here S is a string. And what I want to do is I want to lowercase it and take the white space off from either end and do my comparison. And if I had been really worried about creating temporary objects, I would have had to dream up some method that changes the case and does a trim at the same time or something. But because we have such a well-tuned memory manager, I'm able to create two temporary objects and not have to worry about too much. I say string.toLower. That creates a temporary object, and then on that object I call trim, and that creates a new temporary object, and I compare that to foo. And then when that comparison is finished, those objects are free for the GC to collect. And those objects actually never got out of the L2 cache on the processor, so it was very quick. But I do feel like I need to say all things in moderation. I'm certainly not telling you that memory is now free and go create it willy-nilly. In fact, later on in the deck, we will point out some places where you actually have to be concerned about some memory management issues. So the other big thing about memory management is that we have a non-deterministic lifetime. So that is when we're executing your code and we get to that curly brace, if you're sort of in the C family, or in sub or in function if you're in the VB family of languages. I don't know what it is in COBOL, but when we get to the end of the scope, you're not guaranteed that the object's resources get free right at that time. It's non-deterministic. I can't tell you exactly when they're going to get free. So what does this mean? It means that you should provide a dispose or close pattern to free your expensive resources. So for example, if you look at the database connection object that we have, it has a dispose method that releases that database connection. Of course, you could do that, and you should do that in the finalizer or the finalizer of your type, but it only takes about 2 seconds or so probably before that thing runs. But that 2 seconds could really make a difference in your application if you have many things trying to get those scarce resources. So we provide a dispose method on there. So the user who really knows exactly when he's done with that connection can call dispose and free it immediately. And the other minor point is only implement finalization on classes that need to clean up external resources. For internal resources, we track all the references for you, and we're going to clean those things up. So if you don't need to do that, don't implement the finalizer, because there's a small performance penalty for having that. So you might have heard about reference types and value types. So there are two kinds of types in the system, and that impacts how you design your library. So I want to spend a little bit of time talking about those. So reference types are GC allocated. They're allocated in the managed heap. Assignments are copied by reference. So when I say by reference, what I usually think is, what I really mean is a pointer to. So the entire value is not copied, just a pointer to that value is copied. Arrays are allocated out of line. So that means what I really have is an array of pointers to those objects. And they're passed by reference. So a pointer to that value is passed. Juxtapose that with value types, or structs as they're known in some programming languages. Value types are allocated on the stack. Now, they can reference GC objects so the GC knows where they are, but it doesn't collect those. You don't have to worry about the GC moving those around. Assignments to them are copy by value. So when you assign one struct to another, it actually copies the entire bits over. Arrays of value types are allocated in a contiguous block of memory. There's not pointers to those. It's allocated inline. And they're passed by value. So the entire a copy of that data is passed. So when you say there's two kinds of types in the world, you have to ask, well, how do I convert one to the other? That's an operation called boxing. Boxing changes a value type into a reference type. It essentially copies the value type from the stack into the GC heap and gives it the appropriate GUI to make it an object. And this shows up in languages like VB or C# as essentially a cast to object. So if you were to take an int, which is a value type, and cast it to object, that would create a box. That would box it. And something I want to point out is that's expensive in a tight loop. So if you had a tight loop that all it did was take an int and cast it to an object and box it, eventually you would blow out that L2 cache. You would create more temporary objects than could fit in that L2 cache, and we'd have to go out to main memory, which would slow down the collection. So it can be expensive, and this is a time when you should think about in the code you write, avoiding boxing when it's in a tight loop. And also, as you design your library, you should consider, am I making the users that use my library have to do a lot of boxing? So for that example, let's switch over to the demo machine and take a look at the string builder class. So actually, one thing I wanted to point out here is that this is our reference documentation. I encourage you to take a look at it. It's really very helpful. And if you find any problems with it, there's this nice little link right up here. You just click on that, open a new mail message. And a lot of us at Microsoft are on that alias, and we're sort of looking for your feedback on how to make the documentation better. So if you find any typos or any to-be supplieds where you really need the answer, feel free to do that. Okay, so back to the append method. The string builder class is essentially a custom constructor for strings. It allows you to build up a string as you go. So you might imagine using this using the append method to add ints in a comma-separated list or something to display to the user. And when we had first designed this, we put a method on there that took only an object, and that worked. You pass an int, boxes it. The call is made. We unbox it and add the value to the string. But that actually is somewhat inefficient in a tight loop because you're creating tons of temporary objects as you're doing that. So what we did, you can see we have tons of overloads here. We have almost 15 or so overloads for all the base types, and all those are value types. So if you are passing an int in, there's no need to box here. So you should consider that as you're doing your class library design. So back over to the slides. Okay, so that's what value types and reference types are. So when should I use which? Actually, I think this is one of the times when it's relatively clear. Value types should be used when you need value semantics. So basically, if you're making your own type, if you're making your own primitive value type, such as int. So for example, if you think we totally screwed up the decimal class and 128 bits of precision is not enough for the application that you need, and you feel like you need to write your own, you would probably choose a value type. So if you're writing your own type, our point class in the WinForms package is a value type. So the other thing to keep in mind is we've done a little bit of performance analysis, and value types should really have a small instance size. Because keep in mind, whenever you're doing a method call or whenever you're doing an assignment, you're copying those values, not just a reference to them. So what we've discovered is that an instance size above 16 bytes, it gets to be more efficient to just go use a reference type. And you use reference types everywhere else. To give you some context for this, I did a little looking this afternoon, used the reflection APIs to determine how many types we have in the system. And what kind there are. So there are 6,578 types in the system, individual public types. And of those, only about 112 are value types. So you can see that value types is actually going to be pretty rare if your library is similar to our library. And then most of the rest are reference types. Okay, interfaces versus base classes. The key thing that base classes give you is implementation inheritance. And because you have that implementation inheritance, it provides a lot of power. So we favor using base classes rather than interfaces when you're building up a class hierarchy. That's not to say we never use interfaces. I'll get to that in a minute. But base classes version much better than interfaces. If we try to add a method to an interface, so V1, you ship IFU. V2, you decide, oh, wow, you really needed a method, an additional method on that. you have to create IFU too, because if you add another method, everyone who implements that method already, that interface already, will no longer work. Whereas if you made that a base class instead, you could add that method to it and provide some default implementation to it. So you can see that default implementation for base classes really helps our class library design experience. In addition, because you can provide concrete implementations, you reduce some of the problems that we've seen with other interface patterns. If you look at ActiveX controls, if you've ever tried to use an ActiveX control, most frequently people implement just those interfaces that's necessary to work in the particular container that they're trying to work in, and some containers don't call every method. So for those methods that they never need, they just return impl, right? And then you go and try and use that ActiveX control in some other container, and then it no longer works. And just compare that to the experience with WinForms, where the control is actually a base class. You'll see that we provide default implementations for all the methods on there, and we test it in many containers. So you only implement the ones you care about and let us handle the rest of them. But there is a case for interfaces. Interfaces should be used when multiple routes are required. So if you think that really the hierarchy I'm designing or the base type that I'm worried about, chances are people are going to want to be one of these and also be a collection or also be a stream or also be some other type, then you should consider using an interface in that case. So for example, the iService object provider is an interface we have, and it contains just one method to return the service for a type. We also have the iComparable interface that has one method to do a comparison. And typically these interfaces are going to be very small because they're really not the core thing about what this type is. They're sort of an add-on. So, related sessions. There's some other talks here. I think a lot of these have already happened, but you're more than welcome to check out the slides for those. Also, I encourage you to check out the class library design guidelines. I've really only gone over a subset of the guidelines that we have in the frameworks, and I encourage you to check out the specification we have in the doc set. And then there's a technical overview that includes information about the common language specification. So thank you very much, and I'll take some questions now if you want to find the mics. Yeah.
Just curious. It seems like you've also dropped using like the M in front of member variables.
Yes.
What was the logic behind that? I've been doing some Java programming, and I find it annoying that they don't do that because I can't tell if a variable is a local variable or is a member variable. So I'm curious why you chose to do that.
That's a good point. We did it primarily for consistency reasons. Frequently it's not used, and it gets to be very confusing when it's used sometimes and not used others. So it became much simpler just to say it's not used at all. And as you saw from our patterns, member variables are initial lower. So the member variables as well as parameters are initial lower. So it gives you some clue, but it's yeah. Okay, over here.
In garbage collection, is there any special treatment for cross-references? Like one object refers to other. And
yeah, you are able to have circular references with the garbage collector, and the garbage collector keeps up with them. And if it's a complete circle, if A relies on B, relies on C, but that's it, there's no other references outside, the garbage collection will detect those cycles and collect them.
Thank you.
Yep. Yeah, over here.
So the quick one about threading.
Yeah.
When you're using your built-in types and you're using the arithmetic operators, are they using the interlocked API, or in other words, are those arithmetic operations atomic, or do you need to worry about locking them?
I'll refer you to the IL instruction set specification. Some of the instructions are atomic and some of them aren't. And I don't know the details right off the top of my head, but that information is captured in that specification that ships on the CDs you have.
Okay.
Yeah.
Question about the comments.
Yeah.
Is there a way to turn off the comments in the IDE?
Yeah. Yeah, I believe there is. It's funny you mentioned that. That's been one of the common requests from our developers as we've started to do that. So yeah, VisualStudio.net has a way to collapse those, so you only see the tags for each one. Yeah, I don't remember the key sequence right now, but I'm sure you could discover it. Yeah.
I have a question about your example about base classes versioning better than interface.
Yeah.
I didn't quite understand that.
So, let's think of how the best way to explain it. If I have an interface, let's call it iDispatch, and I define what I think are the set of methods that you need to have on that, and you go off and implement it, so you have an implementation of that. And then I actually change my mind and I decide, oh, okay, actually there was one more thing. We actually need to pass some security goo as well. And so I add a new method to that guy. So now you no longer implement that interface, right? Because you don't have a corresponding method for that type. So in our system, if that happens, when you try to reference the type that you created, you'll get a type load exception because the execution environment won't be able to, you've said you implement that interface, but you don't have all the methods. Do you see what I'm saying? And if instead you had done that as a base class, then you would be able to provide some implementation. And I realize the implementation may not be, it depends on the domain, but it may not be completely the best implementation in the world, but at least you can avoid breaking people who have already implemented. Does that make sense?
It's clear now.
Okay, thank you. Yeah, up here.
I have another question about interfaces versus base classes. With value types, my understanding is that you can implement an interface,
yes,
but not a base class. So might that not be another reason to use interfaces?
Yeah, that is a good example. It is true. The base type for, we've already taken the base type for value types. All value types inherit from system.valueType. So we've taken that already. So if you think you have something that you think built-in types like integer would need to implement, then you would need to have an interface for that. But keep in mind that those types are very rare. The iComparable example I can think of is one of the only ones that a base type might want to implement. So, you know, value types are used very rarely in our system, as it turns out. But you're right. Yeah.
Hi. About destructors.
Yeah.
If everything is garbage collected and resources freed at some point, let's say I open the file and I don't have to worry about when I close it, what's the role of the destructor now?
Yeah, that's a good point. So it's what you say is true. We have what's called file stream class, and we implement a finalizer or a destructor on that. And when that the GC notices no one's using that, it runs the finalizer, and we close the file handle at that time. But what happens frequently is that you end up needing to open that file again. So I'll often write code where I'm appending stuff into a file, and then I open that file up again later in my application. And what happens is, even though that file stream that was, you know, a procedure or so ago away, it's still hanging out in memory, and it still has the file open. So when I go to open it, I get this access exception. So that's sort of a free tip for you. If you ever get an access exception, it's probably because you didn't close your file. So by closing it explicitly when you're done, you're guaranteed that the next guy who comes to open it will be able to. Does that make some sense? Or?
Yeah, it makes sense, but it doesn't answer the question.
Okay,
what
sorry.
Destructor is for?
I'm sorry, one more time.
What destructor is for?
What's the destructor for? Oh, I'm sorry, I answered the wrong question. Destructor guarantees that your resources will get cleaned up. So it's all well and good to provide this close and dispose pattern, but you know as well as I do, some developer who uses a class that you write is going to forget to call it. So it's better to have that thing eventually cleaned up.
So, but the destructor gets called at some point when garbage collector works.
Yes, I'm sorry, I didn't explain that very well. What happens is when the garbage collector notices that no one is referencing your object, it puts it on this queue to run the finalizer. And then it eventually gets around to running that finalizer. It runs the code for it. And then when that run is complete, it frees the memory for that object. So the GC will run that. Will run that finalizer.
At what point the destructor gets called?
So it's non-deterministic. So I can't tell you exactly when because it depends on the load.
It's a function of garbage collector.
It depends on the garbage collector, right? Yep. Yeah, other question?
You were talking about the string class, and you're talking about the 45 cycle allocation, deallocation for heap objects.
Yes.
In most languages, that type of class would actually have two allocations, one for the object and one for the buffer for the string. In C#, is that actually two allocations or one? And in general, with that type of double situation, is the inner allocation on the heap, what I mean to say, is it in the L2 cache or is it in regular memory?
Okay, so that's a good question. So there are a couple there. One is how it sort of goes to how we implemented the string class. And the string class actually is really in bed with a common language runtime, if you will. It's a very special type. So there's actually no like extra character array or some other buffer that we're managing. It's just one blob of memory that we're able to write to. So it's one allocation. But it is like if you thought our string class sucked and you wanted to write your own or what have you, you would probably do two allocations, as you mentioned. And you're right in that often when you create an object, you're creating a lot of peripheral objects as well. And each one of those allocations, I mean, the GC really doesn't keep a graph in that sense. So all those allocations are as if you had done them in line. So the same rules apply. They would all be in the L2 cache as well.
Do you make a distinction when you're making that decision as to whether or not it's an allocation of an array versus an object wrapper?
Well, arrays are reference types. I don't know if I mentioned that in the slide or not. So they would follow the same rules.
So an array can be very big.
Yes.
And that could easily fill the L2 cache.
Yes.
So do you?
Yes, but big arrays are usually not short-lived. Right? Large arrays, the other optimization trick the GC has is the other side of the coin, large, long-lived objects, and that's the case for big arrays.
My reason for asking the question wasn't that I was concerned about the performance of the large array allocations. It's just the opposite. I was concerned about small arrays or medium arrays quickly filling L2. If you guys don't make there's no distinction made. So if it's a small array, then it could go in the L2 cache as well. So you drive everything by the size of the object. You use some kind of internal. Okay.
Yep. So if there's any more questions, I'll be down here. Just swing by and we can talk, or if you want to argue, now's your time.